What I am going to talk about is inspired somewhat by a couple of articles, and you can see my notes here, my extensive notes I took typing on a phone. I have not dry run any of this at all because I think it's a lot more interesting to watch someone like me uh, blunder through it a bit to see like all the challenges. If I face a challenge, you're probably going to face a challenge. And I think it's more educational that way. I want to give a huge shout out to Josh Devins for this blog article, which kind of opened my mind up to the possibilities of using Bayesian optimization for search relevance. He wrote this blog article and just basically tried to, yeah, MS Marco is a question answering data set used in search, but he basically set this up and did a great job. And if you look down here at the bottom, it's actually quite competitive with uh, the. You could read through this article and it's going to talk a lot about what I'm going to talk about. But if you see some of the benchmarks here, like these are is MRR, mean reciprocal rank, like basically the higher this number is, the closer the right answer is to the top on average. On a question answering data set, these are quite interesting because these are, I believe, still fairly, are these still the top non-neural scores? So of course you have BERT and that kind of thing, which I'm sure everyone has heard about for question answering. And these are the current leaders in the non-neural category, which to me kind of opened up, like I had this, I knew that you could optimize search this way, but to me, it kind of like, oh wow, like this is something that we should take really seriously. So I got really into it and I wanted to learn it. So huge shout out to Josh for writing this blog article that I encourage everyone to check out. All my other shout outs here, I want to highlight, of course, all the my coworkers at Shopify were the relevance. So lots of elephant themed stuff you can see here. My cool elephant mask. And the team is phenomenal and everyone's super collaborative between data and engineering to try to make this stuff work. This is one of the tools that we actually use in Shopify search. Andy Touise, who's been really took a deep dive into some of the implementations we have on this and helped to understand and educate the team on it. Trey and Max, co-authors, John Berryman, co-author, and Renee Kriegler for always just being a sounding board for search. Without further ado, let's get into this stuff. So if you brought Hello LTR down, what you can do is you can come here and cd LTR, see notebooks, Elasticsearch, Docker compose up, and this is going to start the Elasticsearch and the Kibana. And next, I'm going to come over here and go into, I'm just going to launch Jupyter Notebook, turn on my virtual environment. Cool. I'm going to pop right into a virtual environment. And I am over here. Let's see if you can browse around. I'm going to focus on Elasticsearch. And at this level, it's the data sets that are available. I have, as a completely other SOP project, which could be a completely other Twitch stream, I've got this Lambda Mart implementation. For those who know what Lambda Mart is, it's a learning to rank algorithm. Basically, a lot of learning to rank algorithms are about like doing some kind of ranking task, which is a little bit different than your typical machine learning problem. So there's often like a transformation to get the data in some form that a traditional machine learning task can take advantage of. And I am happy that I got a pandas version to work that is actually fairly fast and useful, as opposed to all these like hacky pseudo pandas. But I'm going to copy this notebook. Actually, what I'll do, this is, yeah, ESLTR basics. So I'm going to set this up. I'm going to download a corpus and judgments, and I'll show you what this data set is. And rebuild will reindex the data. Yeah, it's already there. So let's see. What is in here? So the first thing that is important, and I think like it's kind of interesting how mind-blowing this can be for people, is just like what is the structure of search evaluation data, and even the idea that you would gather this data. So we have this toy data set, or this toy training set, you could say, around movie titles. It's like a simple, pretty simple use case, but there is a little bit of complexity in it. It's not just about matching titles. There's a little bit of uh, intricacy in it, like Star Wars. A lot of the Star Wars movies don't actually say Star Wars, and so on and so forth. So there's a little bit of complexity, and it's kind of a like, good getting starting data set for this kind of work. But what is in here? So again, we're in a movie context, and you can see here that there's these QID, which corresponds to a query ID one, which is an ID for this keyword Rambo. So this is as if the user typed in Rambo. Same thing, 2 is for Rocky, 3 War Games, 4 Crocodile Dundee, so on and so forth. And these just map the query IDs to their keywords. But what's important, this is kind of a funky file format that is specific to search and learning to rank that some of the libraries understand. But what's important is really this column, which is the query, and even though it's behind a comment, this column, this number. Because ultimately what a judgment is it's basically a 3-tuple, and it forms our training data. It's basically a tuple of what's called a grade, or a label, the query, and the doc ID. Doc ID being, like in this case, a movie ID. So in our case, and the grade can really be any numeric value, can even be a floating point value. In our case, the grade is 0 to 4, with 0 being completely irrelevant and 4 being like absolutely the best, really relevant. And there's, of course, a lot of gray in between. Query is identified with a query identifier, but of course you could also just think of it as like the keywords themselves, Rambo. And then doc ID is, we use this term document in search. It really refers to whatever the entity is being searched. And in this case, it's a movie ID. It's like the TMDB unique identifier of this movie or whatever. And that's really what we have here. We kind of have this data set here. We have a grade, a query ID, and a document ID. So we have that. So you have this cat title judgments.txt. And usually in learning to rank, what I would do is we would build this feature setup. We would say there's a title feature, title match feature, an overview match feature, and add lots of features that we think describe our problem. And we would basically fill out these rows a bit more so that there is a feature vector associated with each of these examples. So maybe for this one, maybe this is the movie Rambo. Whoops. We noticed that like there's a strong title match and also a strong overview match and so on. And a model can start to recognize patterns that like, oh, good, strong movies have relevant movies have a strong title match and that kind of thing. So let's see here. We have our judgment list, and this is it's just like a good enough size to get started. 40 queries. Each query has some relevant, irrelevant examples, and so on. Anyway, so I was saying is usually we would like build a model up. We would build a training set, and a model could learn the patterns of like what predicts relevance within a query. Is it a strong title match? Is it a strong overview match? Is it recent things? Is it old things? Is it a certain, maybe a match in some embedding space? Is it some weird combination of those? Because relevance is often fairly nonlinear. There's often like if this, then that kind of situations. So we would learn those kinds of patterns. But I'm actually not going to talk about that today. I am going to talk about an even simpler way of doing optimization, where you could think about it as I like to sometimes think machine learning is just a series of for loops. And that's kind of the first crack at this. People might be familiar with the concept of a grid search. And so a grid search is basically the idea of doing a large search over lots of different possible values of a query. But the first thing I'm going to do is, let's see here, we have you. Let's see what we can do here. We have the first thing I'm going to need to do here is I'm going to get these judgments. Where are my judgments? Let's make sure we load them up in a reasonable way. Of course, it's going to dump all this stuff out. Let's get the judgments. Yeah, judgments open as a judgment list. And let's see if we can get this as like a data frame or something useful. Let's see here. Judgment list as judgment list. Of course, I made this a context manager way back when. What do we got here? Aha, first we have to import the thing. Just copy all this up here. And let's see what we got here. Judgment list is not defined. It's right there. Oh, we have to spell it. Yes. So we have, what did we put here? I remember there's oh yeah. Okay, so let's just double check that. So in this Hello LTR project, there's a lot of great code. LTR client. What is it? LTR judgments.py? Client judgments.py. Make sure I know what I'm doing. Yeah. Just don't want to cooperate. Okay, so there's a lot of great utilities in here for reading and parsing these files. And the one I want, toDataFrame. So I'm going to bring that in. Judgments data frame. Let's just do this really quick. And none of this is going to be like amazing, super like code you want to ship to prod tomorrow. Is that right? toDataFrame? Yeah. Some wise Alec did this and then had a different naming convention here. Who would do such a thing? toDataFrame judgment list. Let's see what we get here. Judgments data frame. Cool. So you can see here we have a judgments data frame. Now, one of the first things we're going to need to do is I'm going to need to issue a query to Elasticsearch. I'm going to need to take those results back, and I'm going to need to score them somehow using this judgment list. So this is what you might, if you're new to relevance, this is like putting a number on search quality. This is really, really important. I'm going to do something simple. I'm not going to get in the weeds on how this works too much. I really encourage you to look at statistics like discounted cumulative gain, which take into account like whether or not good stuff is showing up at the top or towards the bottom, and weighing accordingly. There's other statistics like ERR, MRR, etc. I'm going to skip all those, and I think we're just going to do something simple with, technically it's called cumulative gain. Sometimes people just say precision, but technically it's cumulative gain, which is really, sounds fancy, but it's the sum of the top n grades for a result set. And you'll see what that means in a second. It's a bit of a show, don't tell. And so let's see if we can talk to Elasticsearch here. So if we come to Elasticsearch, let's make sure we get, do we have Elasticsearch somewhere? Let's see, we have an Elastic client. Yeah. Let's see what's in client.es. So let's just go straight to ES. Client.es, yeah. So this is the Elasticsearch client. And body equals, let's see if we can do something. Match title, or match rainbow. Yeah, it'd be great if we were searching a field. So kind of a simple query, right? Match title rainbow, and you can see, hey, we get rainbow back. So what we need to do is we need to do this for every unique keyword in here. So if we have our judgments, data frame, keywords dot unique, yep, there's all of our things that we could evaluate. And let's just do 4 keywords in fruit, and let's issue a search. And results. And let's see what the, I'm sure that they're keys. Let's see what the, yeah, we want results, hits, which is an array of all the hits. Yeah, so each of these hits has this bit of metadata on it. And really we need to build up, to really score these, we need to compare these to the judgment list, which is our, our ground truth, like evaluation of the search results. I haven't talked at all, by the way, about like where these come from. Like how do we know this is a 4? And honestly, you could spend, and search teams too, spend like 60 to 70% of their time like doing, let me close my door, doing evaluation and that kind of thing. Let's see here. And there is a whole chapter in AI-powered search just dedicated to doing this with click data, and I feel like it barely scratches the surface because there's so many ways this can go wrong. But we're just going to assume this is good for now. For hit in hits, let's just get the, let's just see what we got here. Hit, source, title, perfect, print, hit, source, or sorry, no, I just want to show the keywords. And maybe just a little bit of a, yeah, so we search for, there we go. So we search for Rambo, we get these Rambo, Rocky, we get these movies. Some of these are relevant, some of these obviously, probably aren't, which is, again, debatable. Relevance is hard. This could be subjective. Maybe they are searching for this. But in our data set, they are, that's why we call it a judgment. It's sort of someone made a judgment. But in our data set, they're not. War Games is interesting because the actual movie War Games doesn't have a space. So we could go and solve that problem with relevance if we wanted to. All the Crocodile Dundee movies and a bunch of other stuff and so on. We've got these. And so the next thing we need to do is really like line them up with what's in here.